Good morning, everybody. Welcome back to International Trade. I'm very excited today to continue and finish our analysis of offshoring with a few new models. So the model by Grossman and Rossi-Hansberg is going to be a little different from the model of Finster and Hanson, especially in terms of the prediction. Now we're going to have a small open economy, which is a simple assumption so that the economy takes prices as given. We're going to have two sectors indexed by J and two factors of production, low and high skilled workers. There's going to be a continuum of tasks in each sector. Now the tasks are going to be indexed by I from 0 to 1, and we're going to assume that only low skilled tasks can be offshore. Okay? Now, what's important here is that while in the Finster and Hanson model, the production of an intermediate input required the combination of low skill and high skill labor together, in the Grossman and Rossi-Hansberg model, there is a continuum of low skill tasks that only low skill workers can perform. And then there's another continuum of high skill tasks that only high skill workers can perform. Then the combination of these two continuums generate the final good. So here, really, the model is about, if you think of a factory, in the Finster and Hanson model, we were thinking, okay, you're combining together different inputs, and these inputs use the high skill and low skill labor in different proportions. In the Grossman and Rossi-Hansberg model, there's two tasks, right? There's the task performed by the high skilled workers, the managers, and the task performed by the low skilled workers, say the production workers. And then once the low skilled workers finish their tasks and the high skilled workers finish theirs, then you get the final output. Now, we can assume that also high skilled tasks can be offshored, but for this exercise, we're not going to do so. Now, if the home economy offshores a task, the technology that it uses abroad is going to be the same as the one that it uses at home. Okay. So there's going to be a labor requirement for unskilled labor, AL, of J in sector J. Okay. And we're also going to assume that the wage is going to be lower abroad than it is at home. So imagine this. There is a continuum of tasks that low-skilled workers produce. The unit labor requirement, the number of low-skilled workers you need, is the same at home and abroad. So if the wage of low-skilled workers abroad is lower, why aren't you producing all the tasks abroad? Well, because there is an offshoring cost. Okay? In fact, the labor requirements for a task I produced abroad, not only is the ALJ, the labor requirement that you also need at home, but also this term beta times TI. So beta is just a shifter, and combined with TI captures the cost of offshoring. Now we're going to think that we can rank tasks, not by the skill intensity, okay, because we have low skill task and high skill task separate. We're going to rank them by their offshoring costs. So we're going to think that the initial tasks have low offshoring costs, and the later tasks have higher offshoring costs. So this basically captures a different cost associated with coordination or with communication and so on. You can imagine that some tasks are more easily made somewhere else, whereas others, perhaps they're more related with respect to the other functions in the company, cannot be offshore. Excellent. So now we can figure out in this model which tasks will be made at home and which tasks will be made abroad. If we adopt the same notation that we adopted for the Finster and Hanson model, and so we think that the unit cost C for a low-skill task, so let's call it CL. For a task I at home equals the wage at home times the unskilled labor requirement, AL of J. And recall ALJ is constant. Now in contrast, the unit cost for the same task I abroad is equal to the foreign wage W star ALJ, because the technology is going to be the same at home and abroad. The idea here is again that a multinational that basically replicates its production processes abroad. And so what else is missing here? Because otherwise we would, produce always in the place with the lowest wage. Well, what's missing is the offshoring costs, which are beta Ti. Okay, but so it is straightforward that as in the Finstra-Hansen model, if the unit cost at home, CL, is higher than the unit cost abroad, well, then we're going to produce that task abroad, and vice versa. If the unit cost is higher abroad than it is at home. If WLJ is greater than W star ALJ beta Ti, right, well, we see that here we can cancel out the ALJ. It makes sense, right? If the technology is the same, it's going to play a role in determining where you produce what. And so what we have is that if the wage W, and let's bring over here also the foreign wage W star. So if W over W star, if the home relative wage is higher than the offshoring cost, beta Ti, well then, foreign production. Because this means that the foreign economy has a lower unit cost, right? So vice versa, if the relative wage W over W star is less than beta Ti, what we have is a home production. And of course, of task I. And let me write that also above. All right. Well, what if there is not an inequality, but there is an equal sign? Well, that is what is going to identify our borderline task. We're going to denote this with a capital I. And this is defined implicitly as being W over W star equal to beta T of capital I. Basically, a way to represent this on a plane is just to have on the vertical axis our relative cost, so to speak. So here we have TI, or relative cost of offshoring, as a function of I. And we know that this is increasing because we have assumed that Ti is increasing in I. So this is beta Ti. Right, let me write here just the memory that we assume that T prime I is greater than 0, so that tasks are ranked, ordered by their offshoring costs. All right, and so given that, we can also write a straight line, a straight horizontal line for the relative wage. And so what do we got? Well, what we have is a first part in which beta Ti is lower than the relative wages. And so what you're going to do with that? Well, you're going to do that part abroad. Right? Now, when the relative wage equals beta Ti, what we have is our borderline task. And this is the borderline task, capital I. And then, you know, the borderline task is something that we're indifferent between producing at home and abroad. What about the remainder part? Well, in that case, we're in the other condition, right? In this area, we know that the relative wage at home is lower than the cost of offshoring. And so it is more convenient to produce this part at home. Excellent. So this makes a great deal of sense, right? You know, if you're a firm, you want to offshore, you know that you're basically gonna save money if you produce abroad because you're gonna produce at a lower wage. However, there is an issue of offshoring costs, and different tasks have different offshoring costs. So it makes sense that it is much more likely that you will offshore those tasks that have low offshoring costs, and you will keep producing at home those tasks that have high offshoring costs. So let's think about the zero profit condition. First of all, we know that for I in 0 to capital I, the borderline task, we know that low skill so from 0 to capital I, we have this the low skill tasks produced abroad. And then for I between capital I and 1, we have low skill tasks produced at home. And then we also assume that all high skill tasks are produced at home. So there's no offshoring of high skill tasks. Now this is obviously it's just for simplification. You can easily allow for that to happen in the model. So for the zero profit condition, we know that the price of a good J, or industry J, is going to be equal to its unit cost of production, or its marginal cost of production. And this is going to be a combination of the cost associated with the offshoring, so the low skill task produced abroad, plus the low skill tasks produced at home, plus the cost associated with the high skill tasks. And so let's write this piece by piece. So what are the costs associated with low skill tasks at home? Well, we pay a wage, W, for a unit labor requirement, AL of J. So this is how much we pay to low skill workers for each task produced at home. And how many tasks do they produce at home? Well, from capital I to 1. So the number is 1 minus capital I. And so this is low skill cost at home. Then what do we have? Well, what we have is the low skill tasks abroad. How much do we pay for those? Well, we pay the foreign wage W star times ALJ, that's a unit labor requirement abroad. But then we're going to pay the offshoring costs. So here we cannot simply multiply everything by capital I because that's not the total cost associated with producing tasks abroad. What we actually have to do is to integrate from 0 to capital I beta times di in di. And these are the costs associated with low skill tasks abroad. So this is low skill costs, unit cost, of course, abroad. Is that it? Well, we're missing the high skill task, but that's easy, right? So that is simply plus the high skill wage, let's call it Q, times AHJ, which is the unit labor requirement for high skill workers. Now, what Grossman and Rossi-Hansberg do in their paper is they write a different expression for this, right? But so let's derive that. What we want to do is write the zero profit condition as if it was just a function of two sort of additive components, low skill components and high skill components. So to do that, let's factor out W ALJ, which gives us, well, first of all, it gives us 1 minus capital A plus W star over W integral beta ti in di, from 0 to capital I, plus Q AHJ. Now recall, from our definition of borderline tasks, we can actually rewrite the relative wage as a function of beta and t evaluated at the borderline task capital I. So that hence our zero profit condition can be rewritten as Pj equals W ALJ, which multiplies 1 minus capital I, plus, here we substitute the relative wage, and what we get is the integral from 0 to capital I of Ti in di divided by T evaluated at the borderline task T of capital I. And then we have plus Q AHJ. Excellent. Now, what Grossman and Rossi-Hansberg do in their paper is they define this object here that we derived as capital omega of capital I. And so function of capital omega of I equals 1 minus capital I plus the integral of 0 from 0 to capital I of Ti in the I divided by T of capital I. Now, before we discuss the interpretation for this capital sigma, let us derive the derivative of it to understand whether it's increasing in capital I or not. So omega prime equals minus 1 plus, so let's go derivative of numerator. For that we need the Leibniz rule for the integrals. So we have is T of capital I divided by T of capital I minus derivative of the denominator there. We go integral from 0 to capital I of the I in the I. This is divided by T of capital I squared times T prime of capital I. And here let me write it down just in case somebody doesn't know. We are using Leibniz rule for the derivative of integrals. Okay, so what we have here, well, we have that this term becomes 1, and so it cancels out with the other one. So this is 1, this is minus 1, they cancel out, and so our derivative equals minus the integral of the I in the I from 0 to capital I over T of capital I squared times T prime of capital I. And we know that this is positive by assumption because we ordered a unit cost. So we ordered the tasks by increasing offshoring costs. And so we know that this sigma prime is actually negative. All right, so what is this capital sigma term? The omega is the cost-saving effects of offshoring. Right, so this makes sense. Well, when we write our zero profit condition, we know that omega of I is less than 1. I mean, that makes sense, right? Because otherwise, if we were to be greater than 1, you would have a lower unit cost if you were to produce everything at home. Right? But that is not what's going on. And if you just look at the definition of omega I, you clearly see, right? Since 1 minus I is less than 1, right? So this term is less than 1. And also this ratio here is always less than 1. And so when you integrate it, it's going to be smaller than capital I. And so we know that sigma omega of I is less than 1. But so when you look at the pricing equation, it is straightforward to see omega I as a cost-saving effect, because you see it multiplies the unit cost, the component of the unit cost associated with low-skill tasks, and as you increase capital I, omega declines, and so as you increase the tasks that are offshored, you are reducing omega I, and if you're reducing omega I, you're reducing the unit cost by reducing the part associated with low skill tasks. And you can see here the figure I drew on the iPad on the slide. Right, so here we have our beta times ti function, our relative wage horizontal line, and then the borderline task I. Okay, now our objective is to study what's going to happen with an increase in offshoring, in particular modeled as a reduction in offshoring costs. So if beta declines to beta prime, what's going to happen? Well, our curve there, beta ti, is going to shift downward. As a result, the borderline task I is going to increase up to I prime. And so that means that the number of offshoring tasks increases. I mean, this makes sense, right? It becomes cheaper to offshore for whatever reason. Maybe it's an improvement in the technology, widespread use of Zoom. So what's going to happen is that we're going to offshore more. What's going to happen to the wage of low-skilled workers, holding constant the prices of final goods? Well, and think about it for a second, maybe pause the video, figure out a way to show that. And when hopefully you realize that what we need to do is to look again at the zero profit condition. We drew it before, we wrote it before, here we wrote a pricing equation. We want to know how much a change in capital I, the borderline task, is going to affect the wage. So what we need to do is to take the total derivative of that pricing equation. So let's do that. Well, to study what are the effects of offshoring on the factors rewards, what we need to do, well, we need to take the total derivative of the zero profit condition, like we did in the Stolper-Samuelson theorem. And so what we obtain is that P hat J equals, well, like we did in the Stolper-Samuelson theorem, theta Lj, which is the cost share of low skill labor in product J, times W hat, plus, I guess it's intuitive here to also think that theta Lj multiplies omega hat, capital I, plus theta Hj Q hat. And we know that since omega I is declining in capital I, then an increase in capital I is associated with a reduction in omega. Okay? Great. So let's figure out what happens to the wages and to the high of low-skilled workers and high-skilled workers. Well, here, recall that P hat J equals 0. So if we want to write this in matrix notation like we did for the Stolper-Samuelson theorem, we can bring to the left-hand side the omega hat I, so that we have a vector of theta L1, theta L2, and minus, minus omega hat I, and this is equal to our matrix, which reminds us the same matrix in the Stolper-Samuelson theorem, theta L1, theta H1, theta L2, theta H2, which multiplies the vector of factor prices changes, W hat, Q hat. All right, so we can invert the system. And then if we invert the system, what do we obtain? Well, we obtain that W hat, Q hat equals 1 over the determinant of the matrix, Okay. Then we invert the matrix over there, and that becomes theta h2, theta h minus theta h1, divided by theta L2 with a minus sign, theta L1. And this multiplies theta L1, theta L2. And times minus omega eta I. Okay. So first let us write the determinant. Right? The determinant is theta h2 theta L1 minus theta h1 theta L2. And notice that I'm not gonna make it any simpler. Okay? Why is that? Well, let's solve out that matrix. So W hat equals, we have theta h2 times theta L1 minus theta h1 theta L2, and this is divided by the determinant, which is exactly the same thing. And this multiplies minus omega hat of capital I. And so what is this equal to? Well, the two terms, the numerator and the denominator, cancel out. And so what we have is that W hat equals minus omega hat, which is positive, right? Because we showed before that the omega hat is declining in I and there is an increase in I, then omega hat is negative, and therefore W hat, which is minus omega hat, is positive. So the wage of low-skilled workers increases when we offshore some of the low-skilled tasks. You should think of this as a productivity effect, so that offshoring is kind of like a labor augmenting, in particular a low-skilled labor augmenting productivity shock. By offshoring some of the tasks, workers focus on a smaller set, and since the total number of tasks does not change, right? It's as if they're more productive than before, in a way. To summarize again what we just derived, there is a productivity effect when you offshore more, and basically what offshoring is a labor saving technology, right? Which generate cost savings, which are given to the low-skilled workers. So this is equivalent to a productivity improvement of the low-skilled workers. And obviously, when there is an increase in the productivity for low-skilled workers, you demand more, and therefore you increase their wages, right? Now, this is very important because this is a crucial difference relative to the Finstra-Hanson model. And in the Finstra-Hanson model, if you offshore more, low-skilled workers in both countries were worse off. But that was because the high skill intensity in the two economies was increasing. Whereas here, nothing really happens to the high skill intensity because it's pretty much just the same, right? So, you know, this is a productivity effect, which is very important. And however, we should keep in mind that we're keeping it simple in this class. There's actually two more effects that they analyze in the paper. First, there is a relative price effect, which is a negative effect on the wage of workers. And so there, the idea is that if you offshore more, you're gonna, so if you save on low-skilled workers because the productivity increases, you can imagine that everything has been constant, you know, increase the supply of the goods, so you're gonna reduce the price, in particular of the low-skill intensive good. Right? If in both goods that you have, you offshore more, you save on labor costs, the higher reduction in cost will happen in the good that uses low-skilled labor more intensively. So that if we allow for prices to change, we drive down the price of the low-skill intensive good, and by the Stolper-Samuelson theorem, that will reduce the wage of low-skilled workers. And then there is another negative effect on the wage, which is a labor supply effect, which is basically what we typically have in mind when we think about the effects of offshoring. So if you offshore low-skilled tasks, well, you're freeing some low-skilled workers, right? Some of the jobs are moved, actually not the jobs. Some of the tasks are being produced abroad, and so you need less workers at home to produce the same number of units of output. This generates an increase in supply of these low-skilled workers, which reduces their wages. So how can we think about this particular model and the Finster-Hanson model? Well, we can think about them in two ways. One way is that they work together. You can think that perhaps, to represent more accurately the production function in a given global value chain, what you have is combination of different inputs, like in the Finster-Hanson model, and then each input perhaps is produced with different tasks, some low skill and some high skill. Okay, so the key information that we need to distinguish between the two models in terms of predictions is to figure out whether offshoring is involved in the tasks or whether it's involved in the intermediate inputs. Okay, and depending on which of the two is involved, you'll be able to apply a particular model. Now, I also want to mention here that the Grossman and Rossi-Hansberg model is very successful and has been used a lot, especially empirically, because it has these three interesting effects. Okay, it basically providing a framework to understand under which dimensions offshoring affects low-skilled workers. You can have a productivity effect, a price effect, or a labor supply effect. And so you can imagine that in the empirical literature, what they're trying to do is to quantify each of these three channels. So I want to briefly talk about the model by Costino, Fogel, and Wang, which is just briefly discussed in the new version of the Finstra textbook. And all you need to know is what I'm going to say in this short few slides. And I want to do it for two reasons. First, it allows me to briefly introduce you to a very interesting model, which is often called the O-ring model. And that is something that is very, very interesting, I think. And then it also allows me to briefly discuss this paper by Costino, Fogel, and Wang, which basically they're using a sort of a different approach relative to the Finstra-Hanson and the Grossman and Rossi-Hansberg model. But as you will see, the gist of it will be the same. Okay, so here I wanted to show you just another way of thinking about offshoring and how production is allocated across different countries because of offshoring. But the idea is that you should be able to at least think in terms of these models interchangeably. Okay, pick whatever you find the most appropriate. So let's start with a question of what is an O-ring? Well, an O-ring is this rubber piece, circular piece, right? It's a seal that is used in components of shuttles. Why is this famous? Why is O-ring, why are O-ring infamous? Well, because of them, there was a disaster. And this is the Challenger disaster in 1986. Where basically the space shuttle Challenger burst up, broke apart, just a little over a minute after its departure, and everybody was killed. Obviously, there was a huge investigation as to why that happened, and they found that the culprit was a malfunctioning in these O-rings because there were some unusual temperatures at the point of departures. So I forget if they were frozen or they were sort of damaged by the low temperature, they malfunctioned, and the whole thing burst up. This is, obviously a tragedy, but is an anecdote in a way that has motivated several theories. I remember in some management courses I took back in the day that mentioning the O-ring case is basically a way to focus on the details, because even the small details perhaps may be very, very important. But when we think about this in a model in economics, what basically this O-ring debacle showed was a high degree of complementarity between these intermediate inputs. Okay? Like the production of the final good going into space was a function of several components, each being very complementary to one another, so that if one doesn't work, the O-ring, the space shuttle fails. This type of production function, which is often called an O-ring production function, was firstly introduced by Michael Kramer in 1993. And for this paper, for this model, he actually won the Nobel Prize in 2019, along with two other colleagues in the field of development economics. And here's a picture of Michael Kramer. Now, this O-ring production function is basically a high complementary, is a production function with high complementarity across inputs. So you can think of it as a chain. So it's the weakest, the chain is just as weak as the weakest link. Now, you can imagine that the production of each of these tasks is subject to mistakes, is subject to malfunctions. Okay? And high-skilled workers are much better at reducing the probability of a malfunction, of a mistake, than low-skilled workers. Okay? And so you can picture this as a combination, right, of Finstra-Hanson, Grossman and Rossi-Hansberg, right? Here you can think that they're basically tasks are sequential. Each task can be subject to a mistake. If a mistake is made, the product is thrown away, right? And so you have to start from the beginning. And so obviously you have to choose between low skill and high skilled workers, knowing that the high skilled workers make much less mistakes. When you apply this to the field of development or income inequality, you actually find something very interesting. You find the high skilled workers meshed together. If imagine that there was a soccer team with 10 Cristiano Ronaldo and 1 Luca Macedoni. In this particular framework, that team was just as good as me. Okay, so there's no point in having the Cristiano Ronaldo. It's much more efficient to have a team with just people like me and a team with people like Cristiano Ronaldo. Right? I don't know if that makes much sense, but the basic idea here is if your chain is as weak as your weakest link, well, you're going to have different chains so that the quality of each link is the same to the others. Okay, so you're going to have a high quality chain, medium quality chain, low quality chain. This may sound perhaps reasonable, and I guess it even makes sense, because we know that the best people tend to work together, if anything, because the best companies have the most money, and therefore they can pay the best people to work for them. But what is the problem here? Well, the problem is that maximizes, that magnifies inequality along the skill hierarchy, around the skill rankings, because if high skilled workers only work with other high skilled workers, well, the productivity is much higher than relative to the case in which they were working with some low skilled workers. And similarly, low skilled workers, if they work with some high skilled workers, they have a certain productivity. But if they only match with low skilled workers, the productivity will be much lower. And so if these productivity differences are magnified, so will the wage differences. And you can also bring this up to the country level, okay? So that you can apply this model to the inequality within countries and across countries. Now, what happens if you apply this model to the topic of offshoring? Well, that's what Costino, Fogel, and Wang did in their paper. So they think that there is a sequential production. So forget about the ranking in terms of high skill intensity. Here you're going to rank activities from chronologically. Now, there can happen various mistakes during this production, right? And in particular, they occur at each task, at each stage on the continuum. Countries differ in the probability of making mistakes. You can tie this with the abundance of high-skilled workers, right? We can link this particular model back to the previous two. I think in the perhaps richer countries have higher high-skilled workers, and therefore they have low probability of making mistakes versus countries which are more abundant in low-skilled labor. So what happens? Well, countries are going to specialize in stages in the production according to the probability of making mistakes. The costs associated with making mistakes at the beginning are very low, because if you make a mistake, you have to discard the product. But if you're at the beginning of the continuum, not much has been done yet. Whereas if you make a mistake at the very last stage, that really sucks, because you have to throw away the whole product. And so what's going to happen is that the countries that make the least amount of mistakes will specialize in the later stages. Okay? And the countries that make the most mistake will specialize at the early stages. Now, why? So I guess this makes sense, right? This is another way of thinking about offshoring, thinking, okay, perhaps task, and if we want to bring everything together, perhaps different inputs or different tasks differ in terms of low skill and high skill intensity. On top of that, there is perhaps also a probability of making mistakes. Okay? In countries, we specialize in different portions of this continuum. And what is interesting here? Well, suppose that the complexity associated with the production increases. The marginal benefit of not making mistakes increases. Okay? You know, you can imagine if you make a mistake on the production of a Boeing at the later stage, that is a complex production function, the costs are much larger than if you make a mistake in the production of the tuna, which we saw was like 4 stages. So if production becomes more similar to the Boeing, what happens is that not making mistake becomes much more valued, and therefore there is a higher inequality across countries. If you go the other route, if you standardize production so that you sort of make it everybody, you know, you reduce the probability of making mistakes along the continuum, well, that's going to lead to lower income inequality across countries. Okay, so this was just a short parenthesis, and as I said, everything I mentioned in these few slides, that's all you need to know. Okay? And of course, if you're interested, you're welcome to look up this paper and the one by Michael Kramer. Let's look at Denmark. Now, these last few slides are taken from a paper by Bernard, Ford, Smith, and Brzezinski. It's very recent work. Bernard and Ford are two economists at Dartmouth, whereas Valerie Smith and Frederick Brzezinski are actually two colleagues of mine. They're two professors here at Aarhus University. And what they do in this paper is that they take advantage of some great data that we have for Denmark. Now, this is actually something Denmark is famous for. So there's actually quite a few studies that look at Denmark and mainly because there is such good data. And in particular, there is a survey, right, that asks firms whether they're offshoring between 2009 and 2006. This is very important because we've been talking about offshoring for 2 lectures now, but I never really mentioned about anything about how to measure offshoring. And you can think that that's particularly tricky to do because, you know, when we think about offshoring, we think about production that is fragmented into inputs or tasks, and part of the tasks that were used to be made at home are now made abroad. How to actually account for that just by looking at data on imports is very, very difficult because we don't typically know. Typically, you know, sometimes it is possible, but it's very difficult to actually track offshoring. So actually track a drop in some parts of production and a subsequent start of importing the same part of production. In this case, we do, because firms declare whether or not they've been offshoring parts of production. Now, mostly this is happening with respect to Eastern Europe and China. Well, that's expected, especially between 2001 and 2006. And the main point, there's a few points in this paper, but the main one is that when you offshore, you don't stop producing at all. What you do is that you're probably changing a bit what you are producing. Perhaps you're producing more tech products, perhaps you're producing more high quality products. Okay? Because what they find is that when a company offshores, starts to offshore as they state in the survey, they start importing products. Hey, you can think that we basically know which products firms produce, right? Because they have to fill, if they have more than 10 employees, every Danish company in manufacturing has to fill a survey that declares which products, you take them from a particular classification, are produced. We also know which products are imported. Typically, that's because the products go through customs, right? And according to the particular product code, there is a tariff associated with it, and so we have information on that. And so basically what they observe is that the products that a firm produces keep on getting produced after the firm offshores. Right? So if a firm, if a firm is producing, say, water pumps, okay, and starts to offshore, well, that firm will keep on producing water pumps after the offshoring has taken place. The firm will also begin to import water pumps from the place in which they offshored part of production, but the key is that there's going to be a difference in the prices of the good that you produce domestically and the good that you import from abroad. And in particular, the good that you import from abroad, presumably the one that you offshored, has a lower price than the one you produced at home. So the story here is, okay, you start offshoring, you produce some goods abroad. What that's going to do is going to allow you to produce more high quality goods, which sell at a higher price. Okay, so let's look actually at some figures from their paper, which are not in the article in the reading list. So on the left panel, there is the distribution of offshoring firms across industries. So basically in the survey, the majority of firms that offshored are from the machinery sector. And among the firms that offshore, this is the share of workers So 40% of workers in textile are in firms that are offshore. Same thing for machinery, and a smaller share for the others. Now, there is a key difference in offshoring firms. Here, when we look at these figures, we're comparing in blue the firms that declare in the survey that they offshore. And in the red dashed line, we have the firms in the same sector that did not offshore. Here there's two bars, right? One is at 2001, when the survey begins, and one in 2006. You can see that there is an initial difference between the two firms. Look at the average number of workers, offshoring firms are larger. Right? The firms that offshore are bigger firms. And then what happens to the size? Well, the firms that do not offshore become slightly larger, right, on average, and whereas the firms that offshore, in terms of employment at least, becomes slightly smaller, a bit smaller. What about technology? Well, here we have the share of workers that are categorized as technology workers, and you can see that the offshoring firms tend to be more technologically intensive. And then the share of workers that are of technology workers actually increases way more in firms that are offshores in blue, while it remains almost constant for non-offshores. Okay, so offshoring firms, the firms that do offshore, are bigger and they are more technologically intensive. When they offshore, there's going to be a change in the composition of their labor force. So here what we have is the total number of workers in blue for offshoring firms on the left panel. And you can see that from 2001 till 2006 declines by about 5,000 workers, 4,000 workers. Whereas the number of tech workers from 2001 to 2006 increases. And this is about 2,000 workers. Okay. So what's going on here? Well, perhaps some production workers are not going to be working anymore in those companies, or perhaps the companies are just going to stop hiring, and so production workers that retire don't get replaced. But what's happening is that the number of tech workers is increasing. So basically, as these firms are offshoring, they're becoming more technologically intensive. What about the non-offshoring firms? Well, that is the right panel. As you can see that the total number of workers and the number of tech workers, they kind of move together. Okay, so this is basically saying, okay, they're hiring more workers and they're keeping the share of tech workers the same. Okay, so not only when you offshore, you start producing more high quality goods and you let the offshoring country, the foreign economy, produce the low quality goods, but you also, perhaps related to that, you become more technologically intensive. And you also start spending more on research and development. You focus more on research and development. Okay? So we have here from 2001 till 2006, offshorers start spending more on research and development, and they also start to hire. There's a shift in the composition of workers towards R&D. So this is beautiful because this is perfectly in line with the models that we saw, in particular the Finstra-Hansen model, right? So here we have the firms that start offshoring, and what happens to them? Well, they become more high skill intensive. How do they become more high skill intensive? They spend more on R&D, they hire more R&D workers relative to the total number of workers. They also hire more technology workers, engineers, various college graduates, and so on. And so they become more high skill intensive. They produce the more high skill intensive products, which in this case correspond to a higher quality good of the same product category, that the firm produces. That's it for today. Thanks a lot for watching. I'll see you next time. Ciao.